Lab E-1 is all about electrons and the electrical charge they generate. In this lab, we will investigate how electrons move from one object to another. We will experiment with methods for discovering the number of electrons that have been transferred, the magnitude of the charge, and also whether electrons have been moved onto or away from an otherwise neutral object, the net positive or negative charge. For an excellent conceptual overview of the lab, check out Lisa Hardy's video linked in the description. Students and TAs alike often struggle with this lab. This is mostly because electrons are everywhere. They're building blocks of your hands, your clothes, the lab table, and the air that fills the room. Our equipment treats all electrons equally, so outside influences often get in the way of electrons that quote-unquote should be there. It will require patience and care to make accurate, repeatable measurements. The purpose of this video is to clarify the proper use of the equipment and provide some tips and tricks for getting the best results. Our first task is to create a charged object. The simplest method is by rubbing. When objects are rubbed together, adhesion bonds form which can transfer electrons from one object to the other, depending on the material. This is called triboelectricity. In this lab, you are given 4 materials to charge: rabbit fur, silk cloth, an acrylic rod, and an ebonite rod. In Physics 202, you'll also have 3 paddles of different materials used to generate charges. Please consult the table in your lab manual for help determining the sign of your charged object. Be aware that oils and dirt will affect how a material holds charge. If you're having trouble getting a consistent charge of the expected sign, try cleaning the rods with soapy water. We need to be able to measure the magnitude and the sign of the charge on our charge sources, as well as on our test cases. We'll be using 2 measurement tools in this lab: the electroscope and the Faraday cup. The electroscope is a very sensitive qualitative tool. When a charge is placed on or near the conducting electroscope knob, the electrons in the electroscope assembly will redistribute, resulting in an excess positive or negative charge on the leaves. The repulsive force between these like charges is strong enough to push the leaves apart, with greater charges resulting in greater deflections. Note that an uncharged electroscope reacts identically to positive or negative charges. For example, if I bring a negatively charged ebonite rod near the electroscope, then bring a positively charged acrylic rod near the electroscope, the leaves will deflect identically. Charges can be transferred to an electroscope by simple contact with the charged object. Once the electroscope is charged from a known source, it can be used to differentiate between positive and negative charges. For example, if I touch a negatively charged ebonite rod to the electroscope, then bring a positively charged acrylic rod near the electroscope, the leaves will fall together and then rebound when I remove the rod. When I bring the still negatively charged ebonite rod near the scope, the leaves push even further apart. To discharge the electroscope, simply connect the knob to any grounded object. The electroscopes tend to have few problems. If an electroscope is giving an unexpected result, it is probably an issue with the object you are attempting to measure. Do be careful not to overcharge the electroscope, as this can tear the delicate leaves. Don't use an electroscope with torn or damaged leaves. Just get a new one from storage. Our next measurement tool is the Faraday cup. The Faraday cup consists of a small inner cup connected to a BNC output. The cup is connected by and electrically insulated from a grounded conducting shell, designed to shield the cup from outside electrical influences. Charges transferred or induced on the cup are measured on the electrometer. The electrometer is quite sensitive and capable of measuring accurate voltages from very small currents of electrons. It isn't necessary to completely insert an object inside the cup to test the sign of its charge. Just bringing it close is sufficient. The goal is to induce a charge on the cup that will register on the electrometer. If you accidentally charge the cup directly, it can be discharged either by using the short switch on the electrometer or by connecting the inner cup to the shell with wire. Occasionally, you may need to discharge the rods or paddles completely. The blue and white paddles and both rods are all insulators and may not readily release charge. Holding these rods above a source of ionized air, such as an alcohol lamp or heat gun, will neutralize the charge. Be sure not to get these plastic bits closer than about 6 inches to either heat source. They will melt, and there's no benefit in being that close. We'll need to be able to move charges from our initially charged objects to other test cases. For this, we'll use a proof ball. The proof ball has a solid conducting sphere attached to an insulating handle. We use the proof ball to transfer charge because the geometry holds the greatest charge and retains it for the longest time. Simply touch the proof ball to the charge source without rubbing, and then touch the proof ball to the test case. Large amounts of charge won't transfer, but you should get enough to measure. Please be aware that the handle can become positively charged. If this happens, clean the handle with soapy water and then discharge it with ionized air if needed. When making your measurements, it is important to minimize external effects. Electrical potential is built up just by squirming in your chair, shuffling your feet, or running fingers through your hair. Keep as still as possible to get the best results. Also, some clothing will always carry a relatively large amount of charge. Remove wool, nylon, and especially fleece before starting the lab. Cotton maintains its electrical neutrality well and is great for this lab. Humidity also has a strong effect on charged objects. On dry days, almost any object can cause the electroscope leaves to deflect or the electrometer needle to jump. Any motion is likely to generate a persistent charge. On humid days, the opposite is true. Water molecules colliding with charged objects can very effectively carry off charge before it can be measured. As with any physics lab, patience, care, and practice are required to get the best results. Please feel free to contact Brett Unks or Jim Reardon if you have any questions or comments about this lab.